Okay, this is chapter 2, which will cover on diode. So the first topic of this chapter is on the basic type of diode, which is a PN junction. They call it PN junction. And then the topic on the PN junction, we will discuss on the structure of the PN junction, and then the operation and the electrical characteristic. Okay, so when we say diode, there are some statements or keywords that can be associated with the diode. The first one is rectification. So this is the main keyword that can be related to the diode. Rectification or rectify. What is rectification? Rectification is the conversion of the alternating current, which is AC, to a direct current. So means that alternating current means that it is the wave, the form of the voltage. Let's say voltage is changing with the time. So this is time, and then let's say we have voltage, or AC can be current or voltage. So you see the value of the voltage changing depend on the time. This T is time. So the rectification is converting this type of signal to the direct current. So how the direct current looks like is, direct current, if we draw the voltage versus time for the direct current, the voltage is fixed. So we'll have a fixed value of the voltage. So this is a DC. Okay, so in summary, the first thing that the main or the most associated keyword to the diode is rectification, which is the conversion of AC to DC. Okay, so and then related to the rectification behavior of a diode, so one statement that can be related or can be associated to the diode is the second statement. The diode only allow the current to flow in one direction. So it's only allowed to flow in one direction. And then the third one is voltage limiter or regulator. What is voltage limiter or regulator? Means that the diode, by using the diode, we can fix the certain output voltage to be at certain value. So this is a voltage limiter, or we call it voltage regulator. Regulator means we regulate at certain voltage value. Regulator. Okay, this is how the actual diode look like. This is a typical structure or typical look of the diode. So diode is basically a two-terminal device with two terminal or two connection point. We have these two terminal, 1 and 2 terminal, and then diode has polarity. So has polarity means it has a positive terminal and negative terminal. Positive terminal we call it anode, and then the negative terminal we call it cathode. So when the device has the polarity, so this is we need to take some caution, take some precaution when we connecting the device. So we need to take a look at the datasheet of the device and see how the device should be connected, because it has polarity. Okay, so this is the actual look of the diode. So this is the symbol. This is the symbol of diode. So diode has the anode and cathode. So see here, this one is this line actually representing the line in the actual diode. And then you see this triangular shape. Triangular shape is actually referring to the flow of the current. So positive to negative. So this is anode and cathode. So when you see the symbol and when you have the actual diode with you, first of all you find this stripe or this line. So this line is actually cathode and this one is actually cathode. Okay, first let's understand what the statement of this statement means. The diode only allow the current to flow in one direction. Okay, what does this statement mean? So now I would like to show you the simulation of current voltage characteristic of diode. So current voltage characteristic of diode. So the term is current voltage characteristics means that you are drawing or you are plotting current as y-axis versus voltage. So voltage, current versus voltage. So you want to see how the current of the device changes with the change of the voltage. So this is the current voltage characteristic. So now we want to see how the current voltage characteristic of the diode. So sometimes we call it IV characteristic because this is I, current, V is voltage, IV characteristic of diode. Okay, so in order to simulate the IV characteristic or current voltage characteristic of diode, we use a circuit simulator. So one of the most well-used software is called multisim. I think some of you have used it before during the other subjects in your previous semester. So multisim is a circuit simulator. So this is actually, you should have license, but the good news is for a simple operation or simple simulation, you can use an online simulator. You can go to this website and then you need to sign up and then you can do the simulation. Okay, I have pre-recorded the simulation. So at the left side is the online simulator. This is multisim.com. See, this is multisim.com. And then you can see here I have connected in this, what you call it, in this platform you can connect all the components. Let's say in this circuit we have this is DC source or battery, then connected in series with resistor R1 1 kilo ohm, and then connected it with the diode D1. Okay, so this is positive, this is DC source, this is source positive, the voltage will should okay, based on this polarity of the battery, we can expect the current to flow clockwise. Okay, clockwise, and then you see this positive is connected to the, this is cathode of the diode, and then the anode of the diode, and then the cathode of diode is connected to the ground. Okay, so after we connected the component, then we put the measuring device. So we want to measure the voltage across this diode, so we call it diode voltage, and then we want to measure the current that flow along this or flow across this diode. So this is a current meter, so voltage meter and then current meter. Okay, at the left side I have made the use the Excel to plot the current versus voltage. Okay, let's say we start with 0 volt, there's no voltage, and then there's no current. And then next, I increase the voltage battery DC voltage to 300 millivolt or 0.3 volt. Okay, we change the voltage to 300 millivolt. Okay, and then we execute. simulate, and then we get the value. So the voltage is 0.3 or 300 millivolt, and then the current is very low. This is approximately 1 nanoampere. So nanoampere is 10 power of minus 9. Okay, so I put the value in this table. Okay. So next, I increase the voltage. See, increase the voltage to 600 millivolt, and then see the result. And then we plot this. We have the voltage is around 0.597, and then the current is 33 microampere. So you can see here the current suddenly increased from nanoampere to microampere. Okay, so next we increase to the 900 millivolt or 0.9. So you can get the voltage is you have the significant increase in this current. Sorry, the voltage is around 0.621, and then you can see the significant increase of the current. Okay, this is when we apply a positive voltage. Okay, when we apply the positive voltage, the current will start to flow around this 0.5 to 0.6. Okay, next we need to change the polarity of the battery. So now I'm applying negative 0.3 volt. So when apply negative 0.3 volt, you can see here voltage is minus 0.3, and then the current is minus. This is minus 610 femtoampere. Okay, femtoampere is actually is 10 power of minus 15. 10 power 15. So this is I make a mistake here. Okay, so and then we move to the minus 600 millivolt. So minus 600 millivolt means that minus 0.6. So the current is picoampere. So last time is femto, and then it become picoampere, but the current is still very low. Okay, for the typical device, the current is in microampere to milliampere. Milli to microampere. So if the current is nano, pico, or femtoampere, we can say there is no current, means that in off state. Okay, and then the last one, I increase to negative 900. Okay, negative 900. And then we get still in picoampere, minus 1.8 picoampere. So if you compare minus 0.6 and minus 0.9, there's no much different. There's no much different. And then the current is still very low. So this is our final result. Our final result of the current voltage characteristic of a diode. Okay, so you can see here at applying when we apply a positive voltage, the current can flow. When we apply negative voltage, the current cannot flow. So this is what this show this is what it mean by the diode can allow only for one direction. So only when we apply positive voltage. So in our simulation, the current will only flow in clockwise. In this case, so the current cannot flow in anti-clockwise.